We have a substantial thought of how the universe unfurled from a unique peculiarity 13.8 billion years ago and how the primary stars, systems, and black holes were formed. But what, as a matter of fact, occurred before the Big Bang? Well, Stephen Hawking responded to this inquiry with an unequivocal nothing. After all, time too just began with the introduction of the universe. Anyway, a few scientists have a marginally different belief in such a manner since, in truth, the Big Bang was by no means the start of everything, but simply one of innumerable Big Bangs that are still happening right up until now. Alternatively, this also means that our universe in no way, shape, or form embodies the large picture, but simply a little connection in an infinite chain of universes. But is there any real proof that makes this supposition something beyond an astonishing hypothesis? Better believe it. There really is. The James Webb Telescope has recently recorded a discovery that suggests the nearly unimaginable end, that our reality is currently converging with other universes. When astronomers during the 1920s began to concentrate on far-off cosmic systems, they went over something very startling. They realized that most systems were escaping from us. In fact, this new finding even energized the theory that our Earth could eventually be at the center of the universe. However, the specialists were soon the wiser. Further observations demonstrated that, on balance, not all designs are involved in this cosmic mass departure. In truth, our Milky Way and the Andromeda system are actually moving towards each other to converge in a little more than 3 billion years, as indicated by our present status of knowledge. Anyway, the journey of the worlds initially appeared to be an unsolvable secret, but quite a few years and many detailed investigations later, specialists finally found the genuine explanations for the abnormal universe developments. We now know that, strictly speaking, it's not the cosmic systems that are traveling through space. No, space itself is continually extending. However, the development of the universe isn't exactly as straightforward as it might appear at first glance because it has no focal starting point. On the other hand, this means that everywhere in the universe it appears as though the other substances are getting away from you. No matter which observation point you were to take, it would constantly appear as though you were at the focal point of the universe, from which all remaining designs were escaping at the same moment. However, this seeing also gave another not completely inconsequential piece of data: the actual universe doesn't have a proper center. In simple terms, everything is getting away from all the other things due to enormous extension. But that's not all. Researchers have found that space isn't merely growing, but that the pace of development is actually increasing. As such, the further away a world is from us, the quicker it is getting away from us. In fact, ongoing investigations have shown that 97% of worlds in the recognizable universe are all getting away from us at faster than light speed. But how could this be even conceivable? Doesn't this contradict Einstein's theory, which states that nothing is quicker than light? Well, not exactly. As a matter of fact, Einstein's theory only applies in empty space itself. Anyway, as the universes in reality are very still in space, their development depends on the extension of space itself. As referenced above, no enormous speed limit is broken here. Interestingly, it was even Einstein himself who recognized that such a quicker-than-light speed is conceivable within the constraints of space. The confounding foundation to the huge expansion is that astronomers generally expect that vast expansion began with the Big Bang. This is not really surprising, as space was formed along with matter and time from an original peculiarity. And how should something that didn't yet exist have extended in advance? As the frequently cited start of all that we often imagine, the Big Bang is a savage event where the universe literally detonated into existence. As indicated by this, the beginning of all that once existed, exists today, and will exist later on lay lethargic 13.8 billion years ago in an incredibly hot, thick point. Now, one could envision the corresponding peculiarity as a small dab in the certifiable void. But how does this fit in with the presumption that the universe is boundless? In such a manner, a few specialists point out that the universe should have always been limitless, regardless of whether it is today. Or, to put it another way, the Big Bang didn't occur at a particular point, but all over. This also implies that the main worlds didn't form in a particular region of space but everywhere in the universe. In the same breath, apparently, matter also showed up everywhere in the universe at one point in time. Despite all this, the normal image of the Big Bang still leaves a few significant pictures unanswered. After all, what, in fact, made something abruptly appear out of nothing 13.8 billion years ago? How might something at any point emerge from nothing at all? Furthermore, was there a trigger, or was it pure coincidence? Well, we simply don't have the foggiest idea. The unambiguous answers to these significant questions have forever been controversial among specialists. The baseline is that the theory of the universe's origin alone isn't fit for making sense of all the attributes of the universe that we can observe today. These include, for example, the isotropy of the universe, or, in other words, the way that it generally presents itself to the observer in the same way, no matter what the observer's direction of perception in space. Furthermore, this is where grandiose expansion at last becomes an integral factor. This is a stage of very rapid development of the universe, which is believed to have quickly followed the Big Bang. In the course of this, the universe changed from something small into something essentially larger in under a trillionth of a second. But what was the motor that drove this natural cycle? Well, scientists highlight a mysterious force that is still supposed to drive the accelerated extension of the universe and whose foundation is largely unexplained: dark energy. Webb's mysterious revelation fills an amazing hypothesis right now. However, it ought to be noted that, although dark energy and the related fields are a potential reason for the start of vast expansion, we don't know whether there truly is an association between the dark energy of that time and the dark energy of today. As referenced above, dark energy is viewed as, in current space exploration, the main thrust behind the accelerated extension of the universe. However, although this baffling type of energy has had a firm place in the realm of galactic research for over 25 years, its genuine presence has still not been demonstrated tentatively. Against this background, a few researchers believe that it's possible that it's not really dark energy that is driving the speed-up. Astronomical extension, however, is something that we generally just know from insane science fiction films. Mind-blowing yet evident, a concentration published on December 12, 2023, in the Journal of Cosmology and Astroparticle Physics really concludes that what our instruments see as the development of the universe could, in fact, be the consequence of universe consolidations. To comprehend the foundation of this complex presumption, we first need to take a brief diversion into the world of the Hubble constant. Essentially, it shows how fast the universe is currently extending. However, it also exemplifies a huge riddle in the same breath. If we determine the Hubble constant based on astronomical background radiation, we get a value of 67 km per second per megaparsec. However, as soon as the specialists take supernovae, red monsters, gravitational lenses, and variable stars, so-called Cepheids, into account, the Hubble constant suddenly becomes 73 km per second per megaparsec. In other words, the universe is extending a lot quicker than it should be. But how can that be? According to our theories, space should be growing at the same rate everywhere. One potential explanation is that the estimation consequences of the past were blurred by mistakes and inaccuracies. To see if this is actually the case, the James Webb Telescope recently investigated 320 Cepheids and delivered the sobering yet clear finding that the previously noted deviations are in accordance with reality. So, the error of the Hubble constant is genuine. But how can it be made sense of? Well, Adam Rees, a Nobel laureate in physics and lead author of the study, says that we might have misjudged the universe. There could be forces and cycles out there that we have simply not considered in the standard cosmological model. This could be an extraordinary type of dark matter or dark energy, for instance, but it could be much more notable. Has our universe been gobbled up by another? Jan Amborn from the University of Copenhagen believes it's more prudent to abandon dark energy concerning the Hubble disparity and, instead, consider how possible it is that our reality is currently converging with different universes. Not just that, recently, the actual justification for cosmological expansion is said to have been that our young universe was once gobbled up by a larger parent universe. From that point forward, our universe has been doing likewise to its mother world because, after it was ingested, it crashed into other child universes to eventually absorb them as well. But how do you even come up with such a thought? Well, by working out a numerical model that inspects the impacts that several cooperating universes could have on our universe. The master's estimation showed that the convergence of universes would expand the volume of our universe, an expansion in volume that our measuring instruments, in turn, interpret as a development of the universe. But that is not all. At the same time, analysts also determine the rate of expansion of the universe that would be expected in such a situation. In fact, the corresponding results agreed far better with the observations of space than the conventional standard cosmological model. However, even the most stunning hypothesis must be confirmed by genuinely observational data. But how do you notice an alternate universe in the first place? Well, not by any stretch of the imagination. In order to test the speculation of the consolidation of the universes, specialists are currently conducting various investigations to examine the microwave background. This radiation, a remnant from the time soon after the Big Bang, could thus have some unexplored world qualities that may one day bridge the gap to other universes. And if you want to build a bridge to our recordings on a regular basis, you should click on the approval and the subscribe button now. Join our community and stay updated. We'll see you soon.